So now we're going to be doing significance testing between the proportion from population 1 and a proportion from population 2. Notice that this is my hypothesized value, and this is how you're going to write your null hypothesis. So my null now, when I have two different population proportions, I'm going to see if there is a difference between population 1 and population 2. Notice they're being written with a P and not a P hat because they're coming from a population. So we're going to assume that the difference is the hypothesized value from the problem. All right, so if I say that P1 minus P2 equals 0, which means there's no difference in the value, all right, there's no difference here, then the alternative, okay, is going to be that there is a difference, or we can denote which direction we're going to go. So writing this, what they're showing you here is that writing P1 minus P2 equals 0, or you can just say they're equal. If the two populations are equal, when I subtract them, I would get 0 anyway. All right, and so again, remember in the alternative, we're only going to use greater than, less than, or not equal to, depending on the direction they indicate in the problem. So they are writing it as P1 minus P2 has to be greater than 0, which would make this positive values. P1 minus P2 being less than 0 would make these negative values, and then not equal to just means that we don't care the direction. If the random, normal, and independent conditions are met, we can proceed with calculation. So even with the significance testing, you're going to have to check your conditions, random, normal, and independent, on both sets of data now. That's going to be the big thing, is that now we have two sets of data to check our conditions on. All right, so significance testing here. To do a standardized test, remember we're still using this formula right here that's on your green sheet if you look at it. All right, so if you take a look at your green sheet for me, you're going to see the statistic minus parameter divided by the standard deviation of the statistic. The statistic, what's going to happen is that the statistic is this right here, the difference in the two sample proportions. So the difference in the two sample proportions is your statistic. If you look on your green sheet, it tells you that. Like if I were to pull up your green sheet, look, the statistic is the difference of the sample proportions. All right, so they're already telling you that it's the difference in the sample proportions, which is this right here. And so this is going to be this P1 minus P hat of 1 minus the P hat of 2. This is the difference. That's your statistic. Look that it's under the statistic, so that's what that is. There's not really any debate on that. This is the statistic, so I'm going to take the difference in my proportion 1 sample minus the proportion 2 sample, all right? The parameter of interest is always going to be 0, all right? Because our null hypothesis is going to be that the difference in the two, P1 minus P hat of 1 minus P hat of 2, oops, sorry, not hat in the null, P1 minus P2 is equal to 0, all right? Which is the same as writing P1 equals P2. If they're equal, their difference is 0. But the parameter of interest is always going to be this 0. Okay, so make note of it, guys, that this parameter is going to be 0. Then you're going to have to divide it by the standard deviation of the statistic. Your green sheet, look here, your green sheet tells you what the standard deviation of the statistic is. Here's the formula right here off of your green sheet. Here's the formula that I'm following to get a standardized test statistic, is this value right here. So there's no reason why you should get this wrong if you have your green sheet. You're just following a simple formula. So this is going to become P hat of 1 minus P hat of 2. Technically it's minus 0. It's always minus 0 over, and then here's that big square root where you're going to have P hat of 1 times 1 minus P hat of 1 over N1 plus P hat of 2 times 1 minus P hat of 2 all over N2. So this is going to be your Z statistic for the difference of two proportions. This is my stat right here. Here's my parameter. And this is my standard deviation of my statistic, which is technically, remember that I told you this technically is the standard error. All right? So It's not hard. You're just plugging in the right values. So make sure that you're keeping that stuff straight. Do not get it confused. You will lose your points on that. All right, so here they go. Remember that H naught is P1 equals P2 is true. The two parameters are the same. We will call their common value P. But now we need a way to estimate the P. So it makes sense to combine the data into two samples. This is called pooled or combined sample proportion. All right? So they notice that you have to have this pooled value that you've had before. And it's count the successes in both samples combined. So you take the X1 from group 1 plus the X from group 2 over the N1 plus the N2. So the pooled, okay, in place of P1 and P2 is expressed this way as the denominator. Okay, so now what's going to happen is look what happened when instead of using P1 that we did have in P2, look what we're doing. We're having to use this pooled value. So what I just showed you back here on this screen, actually this becomes P of C, P of C, P of C, and this P of C, where P of C is equal to this pooled value. Okay, it's pooled. And what that means is they took X1 from group 1 plus the X from group 2, so the ones in favor from both groups, over N1 plus N2. And so that's what they're doing here. They have to do it because we assume the true proportions from the beginning are equal. When you do that, when the proportions are equal, that's when you have to use a pooled value. All right? So you use pooled only with a test. Okay, so you're not going to use it with confidence intervals. You're only going to use it with the test, and it's because we assumed that P1 was equal to P2. You don't make this assumption when you do a confidence interval. This only happens for your H naught when you're doing a test, and when that happens, you have to use this new pooled value. All right, that's really, really, really important. So make sure you pay attention to that when I'm doing a test, I'm going to have to do this pooled thing. It's the only time you have to worry about pooling something is when your proportion from population 1 is assumed to be equal to your population proportion of group 2.